Hey guys, this is Miss Bufford, and in this video, we're going to talk about limiting and excess reactants. So your learning goals here are to be able to explain the concept of limiting reactants, be able to identify limiting and excess reactants, and be able to calculate a limiting and excess reactant. So the first thing that we're going to talk about is the limiting reactant. And this reactant is what determines what the theoretical yield of a chemical reaction is actually going to be. And it's also the reactant that we run out of first in a chemical reaction. So it's kind of like when you're baking, and if your recipe calls for 3 eggs, and let's say you want to double your recipe, so you would need 6 eggs. Well, if you only have 5 eggs, you're not going to be able to double your recipe because you don't have enough of one of your ingredients. And that would be your limiting ingredient. And in this case, our limiting reactant just limits the amount of product that we're able to form in a chemical reaction because it runs out before the other reactant. All right, so in order to calculate or perform a calculation that would allow us to identify which one of our reactants is limiting, we have to perform a stoichiometric calculation, or actually several of them. And so the first thing that you want to do always is make sure that your equation is balanced. All right. And then for some of these problems, they actually just give you an amount for each reactant that's present in the chemical equation, but they don't always tell you which product that you're supposed to calculate for. Sometimes they will, but they don't always. And so if they don't give you the product that they want you to calculate for, you just have to choose one and stick with it for all of your calculations. And if this is the case, then I generally pick the one that is going to have the easiest molar mass to calculate. Other problems will ask you how much of something can be produced, and it'll give you an amount for each reactant. And so in that case, you'll have to calculate to whatever product they're asking, for you to calculate, and then determine which one of those reactants is limiting, and then that will actually give you your true theoretical yield. All right, so what we're going to do is we're going to set up a stoichiometric calculation for each reactant that we're given an amount for, and then we are going to determine what the limiting reactant is by looking at the theoretical yields for those equations. And the one that has the smallest theoretical yield is actually going to be our limiting reactant, and that is actually going to be our true theoretical yield. So let's go ahead and take a look at a problem. All right, so in this problem, it says I have 5 grams of oxygen, and this is reacting with 2 grams of hydrogen. So here's what I'm given. I'm going to go ahead and write these underneath where they belong. So I've got 5 grams of oxygen and 2 grams of hydrogen. And it wants to know what the limiting reactant is. And so my goal here is to set up one stoichiometric calculation for each of these reactants. And I'm going to be calculating what the theoretical yield for water is going to be in both of these reactants. And the reactant that produces the smallest amount of water is going to be our limiting reactant. All right, so let's go ahead and set these up. So my first problem, I have 2 grams of hydrogen. That's what I'm starting with. And since I'm in grams and I'm doing stoichiometry, I have to convert that to moles. And so I'm going to divide by the molar mass for hydrogen, which is 2.02 grams of hydrogen for every 1 mole of hydrogen. All right. Then, now that I'm in moles, because I can see that grams of hydrogen will cancel out, now that I'm in moles, I can set up my mole ratio. And my mole ratio here from hydrogen to water is going to be 2 moles of hydrogen for every 2 moles of water. All right, so I can go ahead and put my 2 moles of hydrogen on the bottom so that my moles of hydrogen will cancel out, and my 2 moles of H2O on top. All right, and because this problem is not asking for a specific amount of anything, it's just asking us to identify the limiting reactant, what I can do is I can just stop calculating here and just figure out how many moles. This helps me, save on doing, extra unnecessary calculations. I could convert this all the way to grams if I wanted to, but it's not necessary here because I can compare amounts of water in moles and still know which one is bigger than the other. All right, so if I put this in my calculator, I'm going to do 2 divided by 2.02, multiply by 2, divide by 2, and I get 1 mole of H2O. All right, so 2 grams of hydrogen will produce 1 mole of water. So now what I want to do is I want to set up a calculation for oxygen. So I'm going to start with my 5 grams of O2, and I want to convert this into moles. So I have to divide by the molar mass for O2, which is 32.00 grams of O2 for every 1 mole of O2. All right, and you can see that grams of O2 will cancel out. And now that I'm in moles, I can go ahead and set up my mole ratio again. And this time my mole ratio is going to be 1 mole of O2 for every 2 moles of H2O. And I just want to set this up as a conversion factor so that moles of O2 cancel out. So 2 moles of H2O on top. So in my calculator, I would type 5 divided by 32, multiply by 2, and I would get 0.3 moles of H2O. All right, so when we perform these stoichiometric calculations, let's say for this first one where I calculated for hydrogen, what I'm doing here is I'm making some assumptions. I'm starting with 2 grams of hydrogen, but I'm assuming that I have endless amounts of oxygen to react with all of that hydrogen. And if I have endless amounts of oxygen, then I could potentially produce 1 mole of H2O. But I don't have endless amounts of oxygen. I only have 5 grams. So if I set up this calculation to start with my 5 grams of oxygen, and I try to figure out how much water I can produce with just the 5 grams of oxygen and endless amounts of hydrogen, this tells me that with the 5 grams of oxygen, I'm only able to produce 0.3 moles of water. So after this 0.3 moles of water is produced, I can't make any more water because I run out of oxygen. All right, so 5 grams of oxygen will produce 0.3 moles of water. So this right here is going to be my actual theoretical yield. And you can just say it's the true theoretical yield for this reaction between 2 grams of hydrogen and 5 grams of oxygen. And what this also means is that oxygen here is my limiting reactant. And I'm actually sorry, I need to copy this for the next page here in a minute. Sorry, bear with me for just a second. All right, so this was the true theoretical yield. And this we said was our limiting reactant because it limits the amount of water we're able to produce. All right, which means that hydrogen here is going to be my excess reactant. All right, so I know I'm going to end up having leftover hydrogen. I'm going to use up all of my oxygen, and in the process, I'm only going to be able to produce 0.3 moles of water. All right, so now let's go ahead and talk about the excess reactant. So this is what is left over after the limiting reactant has run out and the reaction has come to a stop. So it's the one that we don't run out of during a chemical reaction, the one that we have left over of. And the way that we determine this is first, we have to use stoichiometry to determine which reactant is our limiting reactant, just like we did in that previous example, where we determined that oxygen was limiting and hydrogen was our excess reactant. Then we are going to take the amount of the limiting reactant, so our 5 grams of oxygen, and we're going to calculate how much of the excess reactant is going to be used up in that reaction. And so that's one more stoichiometry problem that we have to set up and solve. And once we know how much is used up, how much of the hydrogen is going to be used up, we can subtract that from the amount of hydrogen we started with and determine how much is left over at the end. All right, so let's go ahead and take a look at our example. So this is the same problem. And so because we've already solved for this, what I'm going to do is I'm going to paste our work from the other page on here so we can look back at it. I'm just going to kind of squeeze it up here in the corner. All right, so we already determined that this is our theoretical yield. And we determined that oxygen was limiting because it runs out first, and hydrogen is in excess. All right, and so what our steps said to do on the previous slide was we're going to set up a stoichiometric calculation, and we're going to start with our 5 grams of oxygen, and we're going to calculate how much of this hydrogen is going to be required to completely react with all 5 grams of that oxygen. And the reason we're starting with oxygen is because we know that we use up all 5 grams. All right, so I'm going to start with my 5 grams of O2. And I am going to convert that to moles. So I'm going to divide by the molar mass again, 32.00 grams of O2 over 1 mole of O2. And now I'm going to set up my mole ratio. And this time my mole ratio is going to be 1 mole of oxygen for every 2 moles of hydrogen. So don't let the fact that these are both on the same side of this chemical equation throw you off, because that, the arrow doesn't really tell us anything. It's the ratios that are describing the mathematical relationships between all of these reactants and products in this chemical reaction. And so it's the ratio that's important between hydrogen and oxygen here. So what I'm going to do is I'm going to set up my mole ratio. I'm going to put moles of oxygen on the bottom so that it cancels out, and my 2 moles of hydrogen on top. And this time, because I know that I started with 2 grams of hydrogen, I'm going to have to convert this all the way to grams because I'm calculating how much hydrogen was required to completely react with this 5 grams of oxygen. So once I know how much of the hydrogen reacted, then I can subtract that from what I started with and calculate, and that'll tell me how much I have left over. And so what I want to do is I want to make sure that I go all the way to grams here. And so I'm going to multiply this by 2.02 by the molar mass for hydrogen. All right, so if I take a look through here, grams of oxygen cancels out, moles of oxygen cancels out, and moles of H2 cancels out, and now I'm left with grams of hydrogen. All right, so if I perform this calculation in my calculator, I'm going to type in 5 divided by 32, multiply by 2, multiply by 2.02, and I end up with 0.6 grams of hydrogen. And remember, this is telling us how much is used in the reaction. All right, that's just an abbreviation for reaction. All right, so this is telling me that I only used 0.6 grams of hydrogen. But I started with 2 grams, so I have 2 grams of hydrogen that I started with, and I used up 0.6 grams of hydrogen. So if I perform that calculation, that tells me that I have 1.4 grams of hydrogen left over. All right, so this is our final answer right here. This is how much I have remaining. All right, so this type of question can be really tricky. On the test, I could potentially ask you how much was used in the reaction, and in that case, this would be your answer. But if I ask you how much of the excess is left after the reaction stops, then this is definitely going to be your answer up here. All right, so what I would recommend, just to make this really easy for you guys, if you set up 2 lists of steps. One list of steps tells you how to calculate how much was used in a reaction, And then the other list of steps tells you how much to calculate, how much is left over. And that way, when you read through the problem, you can see how much was used up, how much was left over, and you know exactly which set of steps to use to calculate that. All right, so I hope this video was helpful. Please let me know if you guys have any other questions. We will answer questions in class. All right, see you guys then. Thanks for watching Buffered Chemistry. Subscribe to my YouTube channel for more chemistry help.